In this video, we're going to make the connections required from the National Instruments myDAQ to the breadboard for a lab on amplitude modulation that we often do in ECE3084, our systems signals class, or signals and systems, whichever you want to say first at Georgia Tech. So there's 4 grounds that we need to connect. There's the analog ground between the analog output area next to the -15. There's also so this is for the power supply, and then for our measurements, there's an analog ground in between the outputs and the inputs. And we also will want to ground the negative inputs, so our negative analog inputs. So analog input 0-, we'll ground that. And then analog input 1-, we'll want to ground that as well. So I'm going to make these 4 connections over here to our ground rail on our breadboard, which is all the way to the left, this leftmost rail. One thing I would advise caution on is some breadboards, these in particular, the rails do not connect all the way through. They split at this point in the middle. So if you want this rail and this rail to connect, you need to explicitly put a jumper in between those. So that sets up our grounds. Oh, I think it moved ahead a little bit. The first instruction here is actually connect analog output 0. So let's take analog output 0. This is what we're going to use to create our modulating signal. We're going to take analog output signal and put it to pin 1 of chip A. So this one's A, this one's B. We've got pin 1 up here. Let me double check that. Yeah, okay, pin 1's up here. Next thing I want to do is connect the power supplies. So -15 on the myDAQ. I'm going to connect to the -15 rail on the breadboard, which we set up to be the rightmost rail. Then the positive power supply, which is the +15 volts, we're going to hook to the second rightmost, so next to the negative rail. And this is something you'll want to double check to make sure you got those right, because otherwise chips might explode or there might be other kinds of horrible badness. So we do have an issue that although the myDAQ has 2 analog outputs, the function generating software can only drive one of those at once. So to create a signal that can go into the board here, what we're going to do is use a special adapter cable we've made. So it has a 1/4-inch jack on one end, and then it has some leads on the other where we've made black ground as usual. There's a little bit of, had to stick these little jumpers in here to get everything correct in order to put it in the board. And your mileage may vary. We've got several different variations of these. So I'm going to plug this end into the 1/8-inch output of my laptop. Then, of course, I want to be able to figure out where my signal is going to go in. So that's going to go into pin 3 of chip A, which is right here, 1, 2, 3, and that represents the signal that are going in. So the myDAQ's providing the modulator, then the 1/4-inch audio output of your laptops providing the signal that we're modulating. Of course, this guy also needs grounded. I'll just stick him down here. Maybe how about more up here? Oh, come on. There we go. Okay. So we also want to be able to see what's going on here. So let me grab another. Are there any? I think I've used up all the colors I have, so I'll go ahead and just use yellow here because it's in my hand. So analog input 0+. Let's use that to look at the modulator. Oh, actually, no. We'll use that to look at the signal in. So we'll also put that to pin 3 of integrated circuit A, ICA. And then analog input 1, that we're going to use to look at the modulator output. So for that, let's see. What color do I want to use for that? How about green? So there's no magic, it's just largely what's in my hand. So the analog input 1 plus, that we're going to put on to pin 7 of ICA, and that will allow us to look at the modulated output on our oscilloscope software. Now, we'll actually be moving this back and forth over the course of the lab between pin 7 of chip A, which is the output of the modulator, and pin 7 of chip B, which is the output of the demodulator. But in addition to looking at, we'll also want to be able to listen to it. So for that, we have these little adapters that you can plug a 1/8" headphone jack in there. And then the other side of that looks in various ways. Some of these have female connectors on them. This one has a male connector set, and I can't really split those out. They're all together. So what I'm going to do is I need a jumper. I'm going to need some jumpers here. So I'll go ahead and put that, say, over here, and then I'll grab a wire. Just need a more standard jumper wire to connect the grounds. I had a wire for that earlier. Oh, let's see. This is going to be, this is longer than we need really for what we're doing here. But I'm just going to go from the ground here. Should be using black for this or something. But anyway, there we go. So now we've hooked up that ground. Presumably the black wire here is the ground. And the red and white wires here, I suppose, correspond to left or right or left channels on your headphone speakers. And so for that, I'll need to jumper those also. So here, I'll go from, say, this red. Doesn't really matter. It has dawned on me that you could use both speakers on your headphones. You could listen to the modulated and the demodulated at once in your left and right channels, but that's the wrong kind of cord. Okay, so how about this instead? Okay, so we'll go from the headphone output there to, say, in this case, we'll put it to pin 7 of chip A in order to listen to it. So we can see it and listen to the modulated output again. Along with the scope, later in the labs, we'll switch this to pin 7 of ICB in order to listen to the demodulated output. And I think that's all the connections we need. If that isn't all the connections we need and I forgot one, I'll add a comment in the YouTube section.